Now, today we're actually doing inverses, so we can leave that one blank. And we're going to leave this piece over here blank because we haven't talked about odd, even, or neither functions yet. But we can't answer this question in this one. Is this function onto? Well, does anyone remember what an onto function does from the other day? We got one. Yeah, that would make it sort of a relation. That's if it's a function. That's the test if it's a function. A line, where we did an example, a line was onto, a parabola was not. Knowing that, can anybody remember why or what onto means?
Wouldn't that mean that an output only has one input?
That's different. We're going to get to what that is. That means it's one-to-one. There you go. Is this function onto? And we would say yes. All available outputs are used. A, that's how you spell available. Now, I don't know if you will know this or not just yet, but it doesn't matter because I'll tell you how to determine it. Has anyone here, I don't believe we talked about one-to-one functions. Is that correct? We did or did not? We did? Do you remember what it is? Each input has a unique output. The way to test is, does the function, and we'll use the Lazy Larry definition, does it pass the vertical line test, yes or no? So then we know it's a function. It's a one-to-one function if it passes the vertical line test and the horizontal line test. Does this pass the vertical line test and the horizontal? Okay, so this is one-to-one. We'd say yes, because as of now, passes the vertical line test and my horizontal line test. Now, who can think of a graph that passes the shape of a graph that's every day, we could say, we know what it looks like, that passes the vertical line test but fails the horizontal line test? What type of graph would I give that would pass the vertical line test but fail the horizontal? We got one and two of you. Think about a counterexample or something that's a function but not one-to-one. Perfect. Everyone gives a parabola, and that's it. Somebody in the first class said a circle. What's the problem with the circle? Not a function, so how can it be a one-to-one function? Now, we're going to talk, and again, some of this is to get yourselves ready to go beyond. They treat you like little babies, like your minds are so fragile that you can't handle complex mathematics. We're not going to talk about asymptotes right now, or this. This comes from graphing trig. We can answer this, and this looks really, really complicated, and it completely is not. As x goes to positive infinity, what do the function values go to? Well, let's think about that. The function values are the y's. As the x goes out to positive infinity, so function Frank is riding along forever, what are the output values or y values going to as I go out to positive infinity? Hands up, please, if you can tell me where you think that those outputs are going as I go out to positive infinity. Well, we shut down. Abby, what do you think? What are the function values going to as you go out to the right-hand side? What's happening to the graph as you go out to the right-hand side? It's going up. Mm-hmm. Is there a maximum? So what do you think it's going to? What kind of infinity? So as the x's get arbitrarily large, so do the outputs or y's, or the f of x's. Now, knowing that, what would we say about going to the other side? Jessica R., what would you say? As x goes out to negative infinity, what are the function values going to? There you go. Now, the first one takes us like 10 minutes. We're going to get to some that you'll probably be able to answer in its entirety by the time we finish, before the bell is done. Let's bounce over. Have your notes out, please. Open to where we left off last time, which was page 17. Do I have that down right? Page 17. Is that true? Yes? Okay. So, one more, sorry. 18? In the note packets, is it 18? Yes. Okay. Now, you already know what this is going to be. Even if you don't know, you'll initially say, oh, I don't know what this is. Now, there's 4 operations in mathematics. That's it. Addition, subtraction, multiplication, and division. You could make the argument that there's only 2 operations in mathematics. You could say that there is addition and multiplication. You could even argue that there's 1, there's adding, because everything then would have an inverse. Looking at this, what is the inverse operation or opposite operation of addition? What would that be? Subtraction. What's the inverse operation of division? What's the inverse operation of squaring a value? Taking the square root. Cubing it has a cube root, and so on. So if you know that, you know about an inverse operation. Now, on page 18, on the right-hand side, these 3 to 4 things I need you to start writing down. Someplace on the margin over on the right-hand side, probably of page 18, you need to make sure you've got these 4 things down. Give yourself enough space, because I took this much time to type it up, I can assure you. You're going to be using it constantly. Inverses account for about between 6 and 10% of your Regents exam. An inverse of a point goes through and changes the point AB to BA. So if the original graph contains the point 5, 1, the inverse would contain the point 1, 5. If you know 1 point, you know what the point would be on the inverse. If you're given a graph, you reflect it over the diagonal line y equals x. Now, somebody in the other class to start us off today, drop this knowledge bomb on us. How are we supposed to know what the line y equals x looks like? So who can answer that question, how you might have a vague idea of what the line y equals x looks like? So we made something important this week that we were going to use 13 seconds later. If you're given an equation, to find the inverse of the equation, there's no gimmick. We'll show you the algebra and walk you through the process slowly in the beginning. But you take the x and the y in the original, you switch them, and then you solve for the y. Inverse functions, and we'll say this, without knowing what the graph of the original, what the inverse will look like, we know that the inverse will be a function, meaning it passes a vertical line test, if the original is 1 to 1. So a line will have an inverse that's a function because it's 1 to 1. Will a parabola have an inverse that's a function? Why or why not? Will a parabola have an inverse that is a function? Why? Perfect. Perfect. Again, to determine the inverse, you can take a collection of points, transpose the coordinates, and go forward. Same thing would happen if you reflected over the line y equals x, and in an equation you switch the x and the y and solve for y. If the original is 1 to 1, the inverse will be a function. Questions on that? Now, we go through and we do some baby steps on inverse operations. Let's walk this over, please. There's all this stuff that you have for homework. There's a week. All right, so inverses is something that undoes the other. So to start off with, if the function puts on the sock, the inverse would take it off and leave you with an x to begin with. Now over here, the original function x, I add 2 to the input, it gives me 10. The inverse does the opposite operation. So instead of adding 2, what would the inverse require me to go through and do? Yes, subtract 2, and that leaves us with that. And that's how we bounce back and forth between them. If you do in the original, you undo in the inverse to get back the original. Let's say this. If the original maps the point 1 onto a 2, the inverse would map the point 2 onto a 1. Now, look at the original function. Hands up, please, if you can tell me what 3 coordinates the inverse function will have on it. That's the original function. What coordinates will the inverse have on it? No, I need ordered pairs. Well, let's say this. John Paul, what's 1 coordinate on the original?
2.
So what's the inverse going to have?
2 1.
There you go. What are the other 2 points going to be then?
7 2.
And? All we did was transpose the coordinates. That's it. If F is a set of ordered pairs, then the inverse is found by switching the x and y's. Now, as we do this out, you've got to take into account the bigger picture. The inverse requires us to go through and switch the x and y coordinates. So, the domain of the inverse, when we take the domain of the inverse, where does that go? When we take the domain of the original, where does that go in the inverse? Where do the x's go in the inverse? To the range, yeah. So the domain of the original function is equal to or the same as the range of the inverse, and the range of the original function, Erica T, what would that go to? The domain of the inverse. All you're doing, the x's become the y's and the y's become the x's. Questions on that? And let's continue on. Now, this, we try to include it so if you're a visual person you can understand it more whole than just being sort of a robot. When you do this, if I'm evaluating out the function, I plug in something for x. The first operation that I do to the x in order to get an output, let's say I'm figuring out f of 7. Plug in a 7 here, I'd multiply it by 2, and then subtract the 5. Now, the inverse does it in the opposite order and the opposite operation. So instead of multiplying by 2 and subtracting 5, who can tell me what they think the first thing I would have to do in order to get the inverse would be? Close. No? Add the 5. You do the last operation first and opposite of it. So first I would add the 5, and then who can tell me what my second step would then be? So, if I'm taking my input, adding 5 and dividing by 2, that's what the inverse equation would look like. Let's test our answer to see how it works. Catherine, give us a number. Okay. 7. So, sorry, what's 2 times 8? Minus 5. Okay, so we've got 11. Now, Catherine, plug the 11 into the inverse. What's 11 plus 5? Divide by 2. There you go. It's a cycle that repeats. If I plug in an 8, I get an 11, and if I plug in an 11, I get an 8 in the inverse. Here's our equation. Now, we had you write this down. When I ask you what your steps are to find the inverse, you already have them listed out. Go back, I think it was near page 17, we listed them out. Here's what I start with. Y equals 2x cubed plus 7. Who can tell me what my first step is in order to find out the inverse of this equation? You wrote it down previously. I think it's the third bullet that we did. We got one person who can tell me. Go ahead. Okay, so I'm going to switch my x and the y. What would you write out if you switch the x and the y? So I did that. What's the second step that I would go through and do? Who can tell me, please, what my second step is going to be? It's on the sheet. We switch the x and the y. Christina W., what do you say? What would your second step be? Solve for y. So if I needed to get this y by itself, what would you do? Not yet. Not yet. Subtract 7. You take care of what's furthest away first, so I subtract 7. See. Jaron C., what would you do next to get the y by itself? Alexis, what would you do next? You want to say, not square, cube root. Yep. Now, once we get to this step, I would go through, this is a notation issue. Did we ever define this as function f? Yes or no? No. So we can't say f inverse. But we defined it as y, so I would say y inverse is going to be equal to the cube root of x minus 7 over 2. Oh, our steps. Switch the x and y, solve for y, and go through and replace the y that we got at the end with y inverse. Questions on that? Now, what if the function is given as a graph? Go back and check on your checklist. Hands up, please, if you can tell me how we would go about finding the inverse if you are given a graph. Eli, what do you say? There you go. So the first thing I'm going to do is sketch out the line y equals x, and I don't put it as a solid line. Please use a dashed one because it's technically not there. You're just using it to help inform your decision. Now, I look at this and I see easily that there's 3 coordinates on that graph that cross it. Now, here's another one, and I love it. Dr. Welker came over today and he goes, "Oh, I see you were yelling at us for not using Cartesian plane." Absolutely. Absolutely. Now, who here has ever heard of a lattice? Now, we are currently on the Cartesian plane. A lattice point is where the 2 lines intersect, the x grid and the y grid. So, there's 3 lattice points I can easily see on here. Who can tell me the coordinates of one of the 3 lattice points on that graph of f of x? What do you want to say? Okay. Other way around. Negative 1, 0. Who can give me the coordinates of another one? See? 2, 0? No. Hang on. It would be 0, 2. I'm looking for on the original. Yeah. 1, 4. Now, hands up please if you can tell me one coordinate that's going to be on the graph of the inverse. 0, negative 1, so go over 0, down 1, put a point there. Who's got another one we could go through and give? 4, 1, so over 4, up 1. That's the worst line ever. Better, adequate. So, what is this in terms of that coordinate geometry that they love giving you? It's a reflection over the line y equals x. That's the notation to say it's a reflection over the line y equals x. Is f of x a function? So look at that. Hands up, please, if you can answer that question. Is the f of x a function? Oh, by the way, sorry, I'm going to get yelled at for this. Label your graph, please, f inverse of x. Is the original graph, is the f of x a function? Is it a one-to-one function? So without even graphing it, what could I have answered? If it's one-to-one, what do you know? The inverse is a function. So is this a function? Yes. Is my inverse a function? We would say yes, and we know that because the original f of x is 1, 1, 2, 1. Is that difficult? So every relation has an inverse. Therefore, every function has an inverse. Just because we can take an inverse, though, doesn't mean that the inverse will be a function. So, who can give me a type of graph that's going to have an inverse, where the original is a function, but the inverse will not be a function? What's one type of graph that we've done where the original is a function and the inverse is not a function? A parabola. So, here's a graph. Here's my original function. Here's the line y equals x. The inverse is the reflection of this over this line, so it would look something like this. Questions on that? Now, go through right now, please, and find what the inverse is going to be. In number 3, that's the equation. Go through and find your inverse in number 3. Luke, what would your first step be in order to get your inverse? Okay? Wait, before I do that, I'm looking at this right now. What am I going to do to find my inverse? Switch the x and y, so what would you write out? Terrific. What's next? Nick, what would you do next?
Add 2.
So x plus 2 is equal to 3y. Alexa, so what would you do next? So what would your, leaves us with this. Now, I'd say y inverse is equal to this. Now, here's the question that we get into. It's y inverse, but what would you really be expected to give as your final answer? How did it refer to the original function? F of x. So let's make ours F inverse of x. Is that going to be a function? Well, think about the original. Alex, what shape is the original going to be when we do it out?
Linear.
It's going to be linear. Is it a function? Is the original a function?
Yeah.
Is it 1 to 1?
Yeah.
Okay, so what do we know about the inverse? Questions on that one? Now, this is one where we're going to get into a little bit of awkwardness. What shape would this come out to be if I were to go through and graph it out? Hands up, please, if you can tell me what shape this would end up being if I went through and just graphed this out as it currently is. Yeah, it's a parabola. You've got a y squared or some input being squared there. Now, here's the piece that we have to go through and keep in mind. You know what? I'll say we'll see this as we get to it. First thing up, I'm going to write it in y equals form. So this will be y is equal to the quantity of x minus 7 being squared. Well, we can actually answer this now. We need to find the inverse. Is the inverse on this going to be a function? Alex, what do you say? Y. Careful. You said f of x is not what? There you go. Not 1 to 1. So now I'm going to switch these two. So if I switch these two, Jared D, what would it look like? Now I need to go through and solve for the y. So Noah R, what would you do next?
Take the square root with the expression y minus 7.
Now, this is when it gets interesting. Keep this in mind. Who took the square root? Did we take it, or was it already there? Which one? Was there one there to begin with, or did we put it there? We put it there. So a lot of you are going to get this piece wrong right now. When you take the square root, when you introduce it into an equation as plus or minus, we got one last step to do. Talia, what would you do next? So plus or minus root x plus 7 is equal to y inverse. So if I'm going to state this out as a final answer, I guess there's two ways of listing it out. The inverse is equal to the square root of x plus 7, and I'll do it this way because we've already stated it's not going to be a function. Plus or minus root x plus 7. Now, what I'd like you all to do is this. Go in and make sure that you've logged into your calculators. Did I make it so you could? No. All right. You're 3, is that right? Okay. Go through right now. Please log into your calculators. And then once you do, I need you to go into a document, and you're going to add a graph, and you're going to plug in the original equation. So log in. So you can purge whatever's there. Make sure you're using the dots. Now, in F1, you're going to put parentheses, and then the quantity x minus 7 being squared. Is that right? Was it x minus 7 or plus 7? Minus 7, all right. So x minus 7 being squared, and press enter. The next thing you're going to do is you're going to graph the line that you're going to reflect it over to take the inverse, which is the line what? y equals x. So let's go in, please, and let's graph y equals x. Oh, sorry. Just put, no, go back. You only need to put f2 is equal to x. Go down to 3. We'll go down to 3. What is this? Select that. So go into y equals x and hit enter. So that's our second one. And now the third thing that you're going to have to do is this. You're going to go in right now and how many pieces does the inverse have? 2. Keep in mind what's going to happen. I'm taking this graph here and reflecting it over this one. So instead of it opening up like this, can anybody tell me what they think the graph's going to look like when we take and reflect it over that line? We got 2 people. Allegedly, you came from geometry enriched. You should be good at doing reflections. We don't know what that's going to look like if I took this parabola and reflected over that line. What do you think? Yeah, it's going to be a parabola that opens to the side. So go in right now, and in F3 and F4, you're going to go through and graph this out, and it's going to open down to the side. We'll see it may not show up. We may need you to so in F3 you put in the square root of x, then get out of the argument. So the square root of x, and that's when it's plus 7, is that right? Okay, and then you can hit enter, or you can just arrow down, so we need to go down to F4, and then you're going to do negative root x. You're not going to see this piece. You're going to enter one more part, which would be negative root x, because remember we said it was plus or minus, so negative root x, and then plus 7. Now, you're not going to see the inverse directly. Let's go in, please, to menu. We need to adjust our window, which means I'm going to go to 4. Now, the rest of that graph is going to happen up a little bit higher. So press 4. Now, this is what, well, I say it with peace and love. Some of you, they train you. They go, well, what zoom do we do? And this even goes up to calculus. We need to see just a little bit higher than we were at before. Just a little bit higher. So some people start going, oh, you zoom out, you zoom out, you zoom out. No. Think about it. Let's adjust our window settings. So go to the window, and let's change the window by hand. It's not going to, you don't need to be going to MIT to figure this piece out. Our X-min and our X-max. Well, did we use anything over in quadrant 2? No, so we don't need any to show that. So maybe we can make our X-min negative 10. Oh, sorry, negative 1, excuse me, that was already negative 10. Our X-max, let's keep it at 10. That didn't seem to be the problem. Our Y-min and our Y-max ended up being the problem. We didn't have anything down below, so we can make our Y-min, let's say, negative 1. And let's make our Y-max, instead of being like 6, let's make it 20. Some people are like, well, how did you come up with that number? I guess. You could try 27 if you want to. Okay? So go down now, and you can hit OK. Now, this is going to give you hopefully a little bit clearer of a graph. Is this graph reflected over this line going to give me this? Now, there's some scaling issues on it. But if I take this graph and flip it over, this graph would fall on top of the other one. That's how you know that you've got inverses. This piece here, when it looks over this line, sees this piece here, and so on. The vertex, which was here, is now over here. That's what you have to get used to going through and seeing. By the way, if I were to edit this again, do I need to show this much of the y-axis? So let's go in and we'll change it one more time. Go in, please, to menu and 4 for window. And let's go to window settings. The x's seemed okay. Let's make our y-max, let's make it, I don't know, 13. and then graph it? Is that going to make it look nice and easy to do? And click OK. Does that eliminate some of our scaling issues? Okay. Questions on that? Now, let's bounce over, please. For the inverse of a function, the function must be 1 to 1. 1 to 1 if only one, if each y value has only one x value associated with it. So let's look at this original graph. Is the original graph, is f going to be a, is it going to be 1 to 1? What do we say? What do you say? Yes. So we would go through and say that that's 1 to 1, and if you know that it's 1 to 1, hands up please if you can tell me what else we know about it without actually finding it. The inverse is going to be a function. So f inverse is a function. Look at B, and in B,
C.
Leah M, is that 1 to 1? So is G inverse going to be a function? Questions on that? Now, here's one that we're going to encounter that should make you think. Here's my first one. Oh, did we go too much? That's it. Now, I will say this. Go back to this parabola one here, which would be this. Now, here's our problem. And the graph, let's say, looks something like this. The inverse on this, we know will not be a function because the original is not 1 to 1. However, if I was allowed to go through and only look at it through a window, I could make it be 1 to 1. Remember that this reached its lowest point at 7. Right? If I only look and I restrict my domain down, or say I'm only going to look at the x's from here over, is this right now 1 to 1? If I'm only looking in this window, is that 1 to 1? So if I make it so x is less than 7, could we have an inverse that's a function? Yes. What about, well, there's another window that I could look at too that would make this 1 to 1. Can anybody tell me what the other window would be? How else could I view this such that it would be 1 to 1? So x has to be what? If I can restrict my domain. Greater than what? Greater than 7. Sometimes you need to restrict out your window. That way I can get an inverse here that will be a function. Now, let's bounce over to this one here. If I'm finding this out, this is a square root graph shifted up 3. Is this going to be a, well, we'll find the inverse first. If I'm finding the inverse on this, Amanda M., what would you go through and do? Can you keep going? Okay. So I would say F inverse is equal to, now this is where it's going to get dicey. Go in right now, please, and plug in the original. Go into your calculators right now, get a new document going. You can get rid of whatever's there. So let's go. Let's get a new document going. And in that new document, we're going to add a graph. And let's plug in the original, which is the square root of x, then plus 3. I'm going to reflect that over the line y equals x. Now, my inverse is going to happen over here. Now, you're going to see something right away. Maybe it should be a little troubling. So when I take the inverse of this, go in, please, and type in what the inverse that we got was. And what was it? The quantity x minus 3 being squared. Is that right? So press enter. What's the problem with our inverse? Who can tell me what the issue with the inverse is?
It's a parabola.
It's a parabola. So now let's ask this. Which half of the parabola do I need? Remember, it reaches its critical at 3. If this is reflected over this, am I going to need the stuff on the left of the 3 or the right of the 3? The right-hand side. So what would our domain restriction need to be on? So let's go through and state this out. Here's my inverse as long as x is greater than or equal to 3. Because remember, this without that there is too much. You get a parabola when there's that one there. Now, we already told you about this sheet, right? As of today, now you can answer all 6 of them. Somebody was asking before when we have our first exam. If you go through and track, you can check it from the homework calendar or just by our units each day. When we run out of units, or when we run out of days, that's when it is. We're probably about 2/3 of the way through. I think there's 6 or, no, there's 8. How many days do we have on the homework sheet? Take a look in the homework packet. How many days do we have on that? 7. The test is on the 7th day, so you got like 2 days left. We just finished day 4, is that right? So we've got 5, 6, and then your test is on the 7th. Now, I will say this to you all as well. Make sure, please, you're doing the work. If you've got questions, come and ask. I'm not going to collect this from today. But probably tomorrow we'll go through and take it from the author. Okay? How long did the homework take? My apologies, I'm sorry. Now, there's one other thing. You all are lucky because you get to leave here. I, unfortunately, don't. So, before you go, we'll solicit some input. We tried to make it smell nicely in here today. This is, I think, pumpkin swirl. Hopefully, it's good. Maybe some of you are like, it was actually, the morning class was like 60-40 that they liked it, but no one hated it. And the afternoon kids, it was unanimous. 23 out of 23, I think, didn't calculate it. So I don't know if it's bothersome to you. You can remove it, but it smells substantially better than body odor, which is what happens when you don't have deodorant. Sometimes, maybe. So, your homework is to finish up day 4 stuff. You've got 2 days to get that packet done as well. I really overall, though, and to be honest with you, let's set our expectations. At the beginning, it's going to be tough. Things in your expectations, they should get easier as we go along. Oh, one last thing. Turn these calculators over. Make sure you look at the number that's on the back. That's the garage slot. It goes in on the side. Have a great rest of your day, angels. Yeah, this is like an extra. This is so you know where you all stand. Okay? I'll give you, in all honesty, I will probably give you more than you could do. The reason being, I'd rather you overstruct than understruct. Is this the most important thing right here? Probably, right? All right. Thank you.